Alright class, today we're going to dive into the fascinating world of physics and specifically focus on Newton's second law of motion. This law helps us understand how the acceleration of an object is dependent upon the net force acting on the object and the mass of the object. So let's break it down step by step. Acceleration is the rate at which an object changes its velocity. In simpler terms, it's how quickly an object speeds up or slows down. Acceleration is measured in meters per second squared. Now let's move on to Newton's second law of motion. This law states that the acceleration of an object is directly proportional to the net force acting on the object and inversely proportional to the mass of the object. In other words, the more force you apply to an object, the faster it will accelerate, and the heavier the object is, the slower it will accelerate. To put this into practice, let's use a simple equation to calculate acceleration. The equation is acceleration equals net force divided by mass. This equation shows us that acceleration is equal to the net force acting on an object divided by the mass of the object. Let's break it down even further with an example. Imagine we have a car with a mass of 1,000 kilograms and a net force of 500 newtons acting on it. To find the acceleration of the car, we would plug these values into the equation. Acceleration equals 500 newtons divided by 1,000 kilograms. This would give us an acceleration of 0.5 meters per second squared. Now let's talk about the cross-cutting concept of cause and effect. In this case, the cause is the net force acting on the object, and the effect is the acceleration of the object. The greater the force applied, the greater the acceleration of the object. This cause and effect relationship is essential in understanding how objects move and interact with each other in the physical world. Another important concept to consider is the relationship between force, mass, and acceleration. As we mentioned earlier, the acceleration of an object is dependent on both the net force acting on the object and the mass of the object. This relationship helps us understand how objects behave and move in response to external forces. In conclusion, Newton's second law of motion is a fundamental principle in physics that helps us understand how the acceleration of an object is dependent upon the net force acting on the object and the mass of the object. By calculating and analyzing these factors, we can gain a deeper insight into the motion of objects in the world around us. So next time you see an object in motion, remember Newton's second law and think about the forces at play. Thank you for watching, and stay curious. Do you have any questions about Newton's second law of motion, or how it applies to real-world situations? Feel free to ask and we can discuss further. Remember, physics is all around us, and understanding these fundamental principles can help us make sense of the world we live in. Keep exploring and learning, and you'll be amazed at what you can discover.